So this question is from GATE examination 2023, and this question is on thermodynamics part, which is the format of the question is a numerical answer type question. So the question states two identical bodies kept at temperatures 800 Kelvin and 200 Kelvin act as the hot and the cold reservoirs of an ideal heat engine, respectively. Assume that their heat capacity, which is C, is in joules per Kelvin and it is independent of temperature and that they do not undergo any phase change. Then the maximum work that can be obtained from the heat engine is N times C joules. Then what is the value of N? So this is a very straightforward problem. So let us solve this. So let us assume TH and TC are the temperatures of the hot and cold reservoirs respectively, provided that TH is 800 Kelvin and TC is 200 Kelvin. Okay. Also, let TF be the final temperature, or let me say the equilibrium temperature that is a thermal equilibrium of the reservoirs, both the reservoirs. Okay. Reservoirs. Now the heat received from the hot reservoir is QH, which is equals to C times TH minus TF, and the heat to be taken by the cold reservoir is QC, and this is equals to C times TF minus TC. Now here we have considered a unit mass, so Q equal to, you know, that mc delta T. So this is the thing. Okay. Now, so the work done by the engine is, let me assume as W, and this should be the difference between these two, which is QH, the heat that is received from the hot reservoir, and minus QC, the difference between the heat received from the hot reservoir and the heat taken by the cold reservoir. And so this will be given as C times TH minus TF minus TF plus TC. So this will be C times TH plus TC minus twice TF. Okay. So now for a most efficient engine, for most, or let me just remove this A, for the most efficient heat engine, we have the change in entropy to be 0. Okay. Now delta S can be calculated as the integration over ds, and from second law of thermodynamics we know that ds can be written as integration dq by t from second law of thermodynamics. Okay, so we can also write delta S equals to this part we can divide from two parts. First part is from TH to TF, and it should be dq would be C dt again, C dt by T, and the second part should be Tc to Tf, the final temperature. This is also C dt by T. So this would be given as C would be common, ln, and this is Tf by Th for the first integral. For the second integral, this ln, sorry, yeah, Tf by Tc. So now we can use the multiplicative law of the logarithms. So this should be Tf square by Thtc. Now for delta S equals 0, we have ln Tf square by Thtc equals to 0, because C cannot be 0, it will blow up the whole thing. That is, this part should be equal. Tf square equals to Thtc. This will give Tf equals root under Thtc. Okay. So now we need to calculate the maximum work done. So W max equals C times Th, which is 800, plus Tc, which is 200 in Kelvin, of course, minus, I think, 2 times, yeah, 2 times root under 800 into 200. So 8 into 2 means 16, which is 4 square and 100 square. Okay, so it will be C times 1000 minus 2 into 400. So it will be C times 200. That is An equals 200. So this will be the answer. Thank you.